Alright, so there's the agenda. Sorry. I'm just going to leave it up there. Don't miss class after Thanksgiving, because those 3 classes we cover like all of chapter 10 and 11, and that's worth 35% of your final. So don't miss class that day. I kind of screwed up, so I'm not going to go into the stuff, but there it all is. Chapter 10, our learning objectives. This is rho equals 0 is your H naught.
Yes.
Correlation, regression, I'm not going to make people read that again. Just if you're at home, just read that. Pause and read it to yourself. And then pause and read this to yourself as well. Okay. Alright, so this is where we were. So again, your x value, the one you can control, that goes along here. That's the independent variable. You should label it, right? So it's labeled cars. And then along your y-axis, the one you don't, the dependent variable, the one you can't control, that you label along and you put along the y-axis. The x-axis, you just have to go from your minimum to the maximum. The y-axis, you should start at 0, because otherwise you have that non-zero axis misleading graph. So it should start at 0 and then go up from there. So that's the scatter plot. You guys seem okay with that? Remember, this is a positive relationship. Negative would go like this direction. Correlation. Jimmy, go ahead and read.
The population correlation coefficient, denoted by rho, is computed by using all possible pairs of data value, x, y, taken from our population.
Remember, rho, it curls around like that. It's not like p. P has a little thing like that. It's not that. It's rho. It just kind of circles around and loops. Rho, R-H-O. Keep going.
The linear correlation coefficient, denoted by R, is computed from the sample data and measures the strength and direction of the linear relationship between 2 quantitative variables. The one explained in this section is called the Pearson product moment correlation coefficient, PPMC.
Great, and I'll give you guys PPMC tables after Thanksgiving.
Yes.
How about Calvin? Go ahead.
The range of the correlation coefficient is from -1 to +1. If there's a strong positive linear relationship between the variables, the value of
Rho.
R. No, that's R. That's regular R. Rho is that weird P thing. That's regular R.
R will be close to +1. If there's a strong negative linear relationship between the variables, the value of R will be close to -1.
So remember, this is a line, but it's a negative slope line. So anywhere along here, it doesn't say what the slope is, it has a negative slope, but it's a perfect line. If your R is +1, it has a positive slope, perfect line. Here in the middle, and the nice thing is those actually look like, one sort of looks like a line, right? One, it's a line. Versus 0 looks like a circle. No correlation, just a big jumble of dots randomly in this giant circle kind of, right? Round, mix. So that's the easy way of remembering it. Total correlation there, total correlation there, absolutely no correlation here. Okay, so I think you guys did this already, lab problem 3. Did you guys do it or not?
Yes.
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 Yeah,
Yes.
okay. So we'll skip that one, and we'll review this part here. How about Haley? Go ahead.
Hypothesis testing. And hypothesis testing, one of the following is true. H naught rho equals 0. This null hypothesis means that there is no correlation between the x and y variables in the population. H1 rho does not equal 0. This alternative hypothesis means that there is a significant correlation between the variables in the population.
Great. It's always going to be that. H naught is always that something is equal. So it's rho is equal to 0. When your rho is equal to 0, it means no correlation, right? H naught is always no. In this case, no correlation. Rho is equal to 0. If your correlation is close to -1 or +1, then you do have a correlation. you do have a line. And so that would be rho is not equal to 0, H1. It could either be less than or greater than, right? It could be either close to -1 or close enough to positive 1. So rho H naught is that you don't have a line. Your data does not make a line. H1 would be that your data does make a line. Does that sort of make sense?
Yes.
So, in other words, H0 is no line, and H1 is a line. So maybe another way, easier way of thinking about it. Did I just do that?
Uh-huh.
Okay, thank you. So here are the steps again, very straightforward. Step 1, the hypothesis, which we just talked about. Step 2, find your critical value using the PPMC table, which is really straightforward. Step 3, find the test stat. So you guys remember how to do that? You put your list 1, your X values into list 1, put your Y values into list 2, and you do stat, test, lim-merge t-test, and boom, it gives it to you. You scroll, you do L1, L2, enter, and scroll all the way down, and R is at the very bottom. It gives you a whole bunch of stuff which we'll use also, but that R is at the bottom. And then step 4, decide whether or not to reject H naught. So in other words, if you get something, right, H naught says you're right here in the middle, around 0, you've got -1 here, you've got +1 there. If you're far enough away, over here, then you're going to reject H naught. If you're somewhere in this middle, then you're not.
Yeah.
Same as everything else. It's exactly the same as we've been doing in chapter 8. And then step 5, summarize for the claimer variables. Pretty much all the stuff we're going to do in this class is going to be where our claim is H1, that there is a relationship. It is a line. So it's pretty straightforward. So we're pretty much always going to be trying to either support or fail to support our claim. So let's go ahead and I think we did this one with you, but I would like to do, this is the same one? Oh, lab problem 4. Do you guys just want to do lab problem 4 on your own, or do you want me to kind of walk you through, remind you of the one we did before?
I mean, it's okay.
Okay. So, again, here's the previous one, which we did. The hypotheses, H naught is always that rho is
Equals 0.
equal. And then H1 is always going to be what for this?
Rho not equals
Rho
0.
is not equal to 0, exactly. Is no line, is a line. H naught is always no, right? No line is a line. That's our first step. Step 2 is going to be finding your critical value. So here, remember, what's my n here? Right there, right there. Let's stop. How many? What's my n?
6.
6. Everybody see that? There's 6 points.
Yes.
Remember, my degrees of freedom is n minus the number of variables I have. Here I have 2 variables, cars and income, or revenue. So it's going to be n minus 2. So my degrees of freedom in this case is going to be
4.
4. 6 minus 2. So, and don't worry, your table says it right here. Do you guys see that? It tells you. So I'm going to find my degrees of freedom, 4. And then I'm going to do my alpha is 0.05. That's this one. So I want this guy right there. That's my guy. So I'm going to do my little, oops, oh, here. I'm going to do my little thing here. This is my -1, this is positive 1. Here's where my 0 is. And 8.11. Oh, sorry, 0.811, excuse me. 0.811, shade. That's my guilty region. Don't forget it's two-tailed. -0.811 over here. So my critical value is going to be positive -0.811. Step 3.
Yes.
Yeah, find my test stat. So this is how you do it. You're going to write up here. This is my list 1. This is my list 2. It's going to indicate which one you put in list 1 and list 2. And then you're going to do stat, test,
Lin.
Lin Reg t-test. L1, comma, L2. And you're gonna get your test stat. I think our test stat was .982 maybe, when we did this. Oh wait, they tell us what it is. .982. So great, so you're gonna pop it in. Where's it go? Right in here, .982.
That's guilty.
Yeah, see it's totally in the guilty range. Enough evidence. It's not in here. It's way out there. So step 4, reject H naught. And lastly, step 5, enough evidence, because I rejected H naught, to support claim.
Of linear.
Yeah, of, and
Linear
I'd be even okay if you said of correlation
correlation.
or relationship, either one, between
X and Y.
cars and revenue. Cars and revenue. Okay? You guys do lab problem 4.